Okay, so respiratory volumes and capacities. Your lecture notes say that's the amount of air that moves in and out of the lungs depends on the conditions breathing. So inhalation or exhalation, what's happening at the current time. Therefore, we can describe many different respiratory volumes, and you can gain information about a person's respiratory health by measuring specific combinations of respiratory volumes, which we call respiratory capacities. So before I get into these exact, actually, you know what, let's talk about these first, and then we'll talk about the other stuff. So first of all, the first volume that you should know is what is called the tidal volume. Now, this little graph that you see on the left side, this is showing air moving in and out of the lungs. So when you see the curve moving up, that's inhalation. Curve moving down is exhalation. Here's a big inhale, and then moving down, exhale. So upward movement is inhale, downward movement is exhale. So that's what you're seeing on that graph. And so your tidal volume, which is here, just in this space here, and actually I'll use a black pen. So just in this space here is your tidal volume. Tidal volume is the amount of air that you move in and out of your lungs at rest. So this is just your normal quiet breathing is your tidal volume. So the amount of air that you move normally while at rest. And then you have an inspiratory reserve volume. That is the amount of air that you can intake with a forced inhalation. So that's past your normal breathing, past your quiet breathing, the additional air that you can take in. That is your inspiratory reserve volume, which should be about 3,100 milliliters. And your tidal volume should be about 500 milliliters. So you can bring in a lot more air than what you move during rest. Now, I want you to take a really, really deep breath in and then take as big of a deep breath out as you can. Which is a bigger volume? Now, actually, go stay at rest. Now try to take a deep breath out. Just from there.
Okay, I got to do that. All right. Definitely.
Which volume is bigger, inhale or exhale? Inhale. Hey, and you can see that on this graph here too. You can take in a lot big deep breath in than you can from rest blow out. You run out of air much more quickly. So your expiratory reserve volume is the amount of air that you can move out of your lungs past your normal breathing. So not by taking a deep breath in and then out, but just from rest, how much air can you move out past that? It's only about 1,200 milliliters of air. Now, do you guys remember what is the volume of blood in the heart that's left over after systole? What is that called? End-systolic volume. Hey, you remember that we cannot fully empty the heart. There's always going to be a little bit left over. Same thing with the lungs. We will never fully empty our lungs until our last breath when we die. So, not to get all morbid, but you are never going to empty your lungs fully, or else they would collapse. Okay? So there's always going to be a little bit of air left over in your lungs after you've taken the biggest deep breath out that you can. That amount of volume that's left over is called your residual volume. So this is the amount of air that cannot be moved. Okay, you cannot move it out of the lungs. Okay, and you'll notice that the graph that's over here doesn't move into this space. Okay, it's essentially untouchable air, can't move it. Now, when you do breathe in and out, it's all going to mix with each other, but you're always going to have that little bit of volume of air left over in your lungs that you cannot expel. And so there are a few different capacities that you can calculate by adding a few of these volumes together. We're not going to talk about functional residual capacity, so you can, well, if you're using the slides, you can cross that out. In your tables, it's not even included. So you have what's called an inspiratory capacity. That's the total amount of air that you can bring in. So that's your normal resting breathing plus your reserve volume. So both of those two together are your inspiratory capacity. That is the maximum amount of air that you can bring into your lungs, which is 3,600 milliliters. Your vital capacity is all of the air that you can breathe in and out at rest and forcefully. That is your inspiratory volume plus your tidal volume plus your expiratory volume. All of the air that you are capable of moving is called your vital capacity. So that's the air that's going to contribute to your body functions. The movement of oxygen in, CO2 out. All of that is the air that's going to keep you alive. So that's your vital capacity there, which is about 4,800 milliliters. If we were to add all of the volumes together, your inspiratory reserve, your tidal volume, your expiratory reserve, and the amount of air that you do not move, add all those four together, and that gives you your total lung capacity, which is about 6,000 milliliters. Now I'm going to tell you to know these volumes. You don't have to memorize the capacities, but you need to know which ones add up to make those capacities. So like on an exam, I would give you a chart of volumes, and you would have to know which ones to add together to get your inspiratory capacity or your vital capacity or your total lung capacity. Okay. So you'll be given the volumes. You just have to know which ones you have to add together. Okay. Questions on that? And then over there, those are all like just visual representations of how much air you normally move, how much you can bring in, how much you can push out, and then your total, your respiratory, what's that last one? Respiratory reserve volume? That should be it's about 3,000, 3,800. That's probably your vital capacity. I'll have to go look at that in a second. But they're supposed to just be visual representations. Now, I do want to talk a little bit about spirometry, which is going to help you with your case study today. So spirometry, and this is already in your lecture notes. So you don't have to write it down. You can if you want to, but you don't have to. It's already in there. But spirometry is a clinical test to measure volumes and lung function. And it helps distinguish between obstructive pulmonary disorders. So obstructive pulmonary disorders are the ones where you can't get old air out. So this is like COPD, like bronchitis, like emphysema, your chronic pulmonary disorders. But it helps you distinguish between obstructive and restrictive pulmonary conditions. A restrictive pulmonary condition would be something like asthma. So I'm going to talk to you a little bit about tests that are run. So tests that are run, one includes your forced vital capacity. This is where you take a deep breath in and then out. So they have you take a really deep breath in as much as you can, and then breathe all that out as much as you can forcefully, and they measure the amount of air that's been moved. You do it through a tube. And then they'll also measure something called, and this is FVC, they will also measure your forced expiratory volume. So just breathing out. And they measure it at different time frames. So they'll measure it at half a second, They may measure at 1 second, 2 seconds. They do it at different intervals. And this is called FEV, forced expiratory volume. So you'll have an FEV 0.5 where they measure it for half a second. FEV1 where they measure it for 1 second. FEV2 if they measure it for 2 seconds. Okay, that's how they name them. So from these two different volumes that they measure, if you have a low FVC, where you take a really deep breath in and out, this usually means you have a restrictive pulmonary condition like asthma, where the issue is that you can't get new air in because your airways are restricted. Somebody with asthma has a narrowed airways. When they have an asthma attack, it gets even more narrowed than what it already is. That's a restrictive pulmonary disorder. Now for this forced expiratory volume, your FEV1, which is the amount of air that you can blow out in 1 second, should be about 80% of your FVC, which means that you should be able to blow out in 1 second 80% of the air that you can get in and out. You should be able to push out most of it in just 1 second. Okay? If it's less than that 80%, that means that you have an obstructive pulmonary condition. And in this case, you can't get old air out. And this would be like something like COPD, which could be chronic bronchitis, which could be emphysema, things like that. Go ahead. So again, you should be able to get the bulk of your air out in 1 second of forcefully exhaling. If you don't, that means that there's something obstructing that air from getting out. That means you do have chronic bronchitis or emphysema, some other form of COPD. Now, how they can tell, because if your FEV is lower than 80, at first, you could have either one, obstructive or restrictive. But how they can tell the difference between obstructive or restrictive, like with asthma, what they'll do is they'll have you measure that FEV1, so they'll have you blow out in 1 second. If it's not 80% of your FVC, if you can't blow it all out or most of it out in that 1 second, what they might do is have you take some albuterol, which is an inhaler, so the steroid that you take for asthma. They'll have you take some albuterol, and then they'll have you do the test again. And then if it's improved, then you most likely have asthma. They can prescribe you an inhaler, and then you're done. Okay? But if it doesn't improve with albuterol, that means that you probably have a COPD kind of condition. Okay? So they use these tests to be able to tell, do you have asthma or do you have some kind of chronic pulmonary disorder? Okay? So based off of that, what do you think today's case study is? Asthma. All right, so that's it for respiratory volumes. You can answer the questions based off of what we talked about in your lab.